So, my dear students, what I need to start today, we need to start the about the new model that is a decision tree. So, what is mean by the decision tree and where we can use the decision tree? So, I have divided decision tree concept or decision tree model of the machine learning into the three different classes, maybe the four classes, of course, followed by the practical as well. So, what I have decided first, I will tell you the introduction of the decision tree or introduction about the decision tree and what are the various application where we can use the decision tree. Next class of the decision tree, we will see how to build a decision tree followed by the its mathematical computation. So in the next class, of course, you will see how to build the decision tree. Thereafter, if there is some question, some doubt, then we will see, or later on, we will see the some practical session. And I have so many exercises about the decision tree. So I'm just planning to offer the best solution in from the practical. So definitely you can understand in simple way. So I have the solution, the 6 to 7 different kind of the examples, but I'm choosing the best one to explain my idea, what I need to do. Okay, so don't worry about that part. So rather than the understanding the practical part first or other concept, first we need to start the decision tree. So here decision tree is basically is what? Decision tree is basically is a machine learning model. It is an algorithm which can come into the supervised learning. So as our supervised learning is saying to us, when you're looking for the data in from the continuous nature, so definitely decision tree play important role. But there is a beauty of the decision tree, and definitely you will see into the coming slides, of course, followed by the some other slides. Decision tree only the one kind of the machine learning model which follow the two kind of the approaches. One is the regression and classification. So decision trees support the regression approaches as well as the classification approaches, and that is the beauty of the decision tree. But sometimes, whenever try to implement decision tree, so we need to understand what kind of decision tree we are implementing, and that is depend on the problem. So we need to understand what is the problem we have, and according to the problem, we will decide the decision tree based on the regression and decision tree based on the classification. Of course, today introductory part you will see all these concepts. So the fundamental part of the decision tree is necessary part. So I'm going to start my lecture by taking the first term, that is the decision tree. So in the decision tree, you can see the basic term we have over here, decision tree. As the name suggests, as a decision tree. So a representation of the our this model will be informed the tree nature. But what is the objective of using such kind of the representation? By this kind of the model, the representation will be the tree nature, but we will choose the decision, or we will select the appropriate decision based on our representation of tree. So just like example of the tree you have seen into the data structure. So what is the tree? Tree contains the various kind of nodes. It contains the root node and leaf node, okay, and internal node, left node, right node. So many things. The same thing, of course, we will do. So before jumping the different kind of the example, let us understand the fundamental part. What it mean by the decision tree. A decision tree basically has many analogies in the real life application turned out. In fact, it is influenced by area of the genome, and it covering the both classification and regression. That is the point you know to keep in mind into your entire life or whenever you're feeling the understanding about the machine learning. And that is only the one and best approach which describe the both kind of the thing, that is the classification and regression. But how do you choose or how will decide to choose the appropriate decision tree? And it's of course based on the problem. So in decision analysis, what we need to do, we need to decide our representation in form of the decision tree. And as we know, the tree will be representation from the visual manner. Okay, so we know what is the flow of the thing, flow of the information. So we can easily choose, we can easily decide what would be our next decision. Let us take an example. Suppose you want to go to the market, then you have the two options. Either you can walk, or you can choose a motor vehicle or a motorcycle, maybe a different kind of the vehicle. You want to go to the market. So what is the you have option? You have the two options. One is either you can walk or vehicle. Suppose you need to visit the market which is 6 kilometers far from your home. So definitely rather than the walk, you will choose the you will decide the it is better idea to go by the bike or vehicle. But your market is very close to the 100 meter, 200 meter from your home, so definitely you choose the buy profile. So how you're deciding the thing, that is the point which you know is the receipt. So what is the at the first level what you have chosen? You have chosen you need to go to the market, you need to visit the market on the basis of circumstances. The point you need to keep in mind, on the basis of circumstances or on the basis of your need, you will decide the appropriate decision, and that is known as the selecting the best decision or selecting the best uh, attribute at the moment, and then you can move to the next point. And with the help of some real life example, then you will happy to know the answer about the decision tree. So this is just idea about the decision tree, and we will represent such information through a tree manner. So we are representing the our problem by the decision tree. And that is one point you need to keep in mind. Decision tree is the best approach which covers the classification and regression. So here we have some theoretical aspect by which you can understand each and everything what I spoke over here. So you can understand decision tree basically represented by the very single node. What is a single node? Of course, that is a root node. So just let me draw this point. See, you are having some problem, but after getting the solution of the such problem, you are having the two decision. Either you can choose this one or you can choose this one. Maybe you can have the many options, no problem. But right now I'm taking only two part. That is identify the left part or right part. After deciding your decision, and after reaching at this point, you will choose some another decision depend upon your requirement or depend upon your condition. Suppose I'm choosing the left part over here. See, I'm just move to here and I need to move here. Then we can do it. So what you are doing based on some condition over here, that is X condition, you are choosing the left. You are choosing the decision on the left side or right side. And on the next level, just like the Y here, this is a Y condition which is followed by the left node. You're deciding the next condition. So you are filtering your information based on our parameter. Same example, I'm focusing on your visiting the market. So after visiting the market, you found that required product you should choose. That is, you should purchase vegetable and or you should purchase some chocolates or other things. So depend on your budget, how much money you have in your pocket. So based on your money, based on amount, based on your first budget, you will decide the next item or next item should be purchased or not. And that is the point. What is the condition? How much money you have in your pocket. And what is the previous condition at the root level or previous first level? That is the you should go to the market by the car or by walk. Okay, so that is point. So this flow will go on in the smooth way, and that is to be represented by the tree manner. So that's why it is known as the tree representation. So that's why it is known as decision tree, because on the each and every level you are taking the some decision, and representation of the such flow or info your information will be represented by the tree manner. So entire shape will be look like the tree will. So this is the decision tree. Theoretically, I'm just put it over here for notes purpose only, so you can read out in detail. Okay, so there will be notes. But there are internally we have some mathematical some computations. It is not easy to understand how we are choosing. Okay, manually you can do, but practically on the machine is not easy to understand. Machine requires some mathematical computation to choose the appropriate decision, and that part under come into the building a appropriate decision tree followed by the some approaches. And I will tell you into the next class how to build the decision tree followed by the entropy and information gain, and we have an algorithm that is known as the iterative dichotomizer tree algorithm. So with the help of that part, I will tell you, but that would be considered as a part of the next class. But here we need to understand the fundamental part. Okay. Now this is introductory part about the decision tree is clear to all. Yes, tell me. Introductory part about the decision tree is clear all. Yes, will
Yes,
tell.
sir.
Yes, sir.
Okay. So you will happy to see the some we have over here. So I will telling my example in simple way, then you can understand. I'm explaining this example, and this example will contain the independent variable that is a play. So understand. P is what P is means play. Play is a dependent variable. So your playing probability, playing approach is depend upon your weather. So W is a weather, and it contains the some weather, just like it's sunny, it's overcast, or it's raining. So W is the weather, and P is our play. That is a dependent variable, and W is independent variable, and it contains only three different independent variables followed by the sunny, overcast, and rainy. So what we are calling here, we are understanding this problem by help of the regression approach. So you can see there are the total how many people, there are 22 people. So if I'm adding all these values, then you can understand there are 22 people here, and from the 22 people, 22%, 13 people are ready to play game, and game could be anything. Don't worry about the game, but right now we need to understand what is our problem. So 13 people are ready to play the game. 9 people are not ready to play the game. Somehow we have managed, depend on the weather condition. Other person will decide should we play the game or should we stop the game or not play the game. From this point, the total number of the sample we have the 22. So we can say this is the total number of the sample, and that is a 22. From this point, we can found 13 people are ready to play game, but 9 people who are not ready to play the game. So we can easily determine the probability. So how we can identify the probability of the play over here? That is a 13 divided by 22. Simple mathematically. And now for understanding purpose right now. And what is the probability of the don't play game? We have the 9 divided by 22. Just let me know. This is the fundamental step is clear to all. This is the fundamental step. Is it clear to all now? At the first level, is it clear? Step by step, I will ask you. Please tell me. Is it clear to right now?
Yes, sir. Yes, sir.
Okay. But from this 22 data, we found some information that if weather is sunny, okay, please understand this point. If weather is sunny, then only 6 people are ready to play game, and don't play people will be the six. It means 6 people are ready to play game, and the don't play people are six. This is the information we found over here. And if weather is overcast, then 4 people are ready to play game, and one person who is not ready to play the game. If weather is forecast, and if weather is rainy, then only the 3 people are ready to play game, and don't play people. We have total two. So here you can see six. Here I can write over here the 6 plus 4 plus 3 total. We have the 13. It means you can see over total play we have the 13. So all the values are meeting to over this condition. Here we have the don't play conditions. We can write 6 plus 1 plus 2. So we can say 9. So we can easily determine we have the total value like 9. So it means we have filtered our information based on the condition, and we have divided our person based on the condition of the whether are they interested or not. Are they playing or not? Based on the other condition, we are more filtered our information based on the other condition as well. Suppose weather is sunny and 6 people are ready to play game and 6 people are not ready to play the game. But suddenly we found that during the weather case of the sunny, there is some chance humidity. If there is a humidity, suppose humidity is less than 70%, then from the 6 people, 5 people are ready to play game, and don't play people are ready to three. So from the 6 people, we can say from the 6 people, only 5 people are ready to play game if humidity is less than 70. And if humidity is less than 70, then among the 6 people from this point, we will see on this point, from the this point and this point. So only 5 people are ready to play game, and don't play people we have the three. In case If humidity is greater than one person is ready to play game, and we have the person, there are three people who are not ready to play the game in case the humidity. So humidity, when we have the humidity is greater than the 70. So here we have filtered our information. When we filter our information, we need to filter our information to decide our appropriate option and to take the decision. Here finally we got the answer. Overcast is a weather which cannot be explained more. But sunny and rainy are the two weather which can be extended as per requirement. So if I'm observing over here, if weather is runny, no problem, but maybe some chance wind may blowing very fast. So if there's a weather is rainy, but along with the wind. So what we are observing over here, if wind is blowing very fast and very and is heavy rain we have followed by the wind. So only two people who are not ready to play game, only no person is ready to play the game. And who will like to play the game along with the rainy and followed by the heavy windy season. So it is not a good idea, but we have decided our information about it. And now you can see over here from the three people who are playing to game in the rainy, we found that if wind is not blowing in very fast, so three people are able to play game. So we are filtering our information based on our decision based on the condition. Now condition is what? Humidity, windy, and outlook. And that is where that we are looking say. And this simple example, we can say we are finding our information. So what is the dependent variable? Play. An independent variable is our weather. So based on this point, we can represent our information. Here we have the multiple independent variable. What is the weather condition or weather we have over here? So we are categorize our information in from the regression. So in the regression, what we have observed, you have seen it could be dependent variable, but dependent variable. But in the regression, we can have the multiple independent variable and one dependent variable. So there would be only one dependent variable, that is the play behavior here. Rest of the thing we can say independent variable. For but what is the condition on which we are doing? We are trying to planning to play the game. That is the point. And this simple example which describe the entire information to the tree manner. You can say this is the point. Okay, so this is what the first part, that is the we have the total number of the sample 22. This module or this node represents a root node, and we are expanding our node by the different ways. So we have the sunny, overcast, the rainy. So we have the different sub nodes, and the sub node or sub child we can say, or child it can represent by its own representation. So in case of sunny, we have its own children. So we have the less than 70, greater than 70. Overcast does not have any kind of children. Rain is also identified by based on the windy. So we have the true or false. So we have the condition. We are categorize our information level by level, and that is simple thing. Yes, tell me. Any doubt over here? Any student who have any doubt? It describes the representation of the our information in terms of the decision. What decision we need to take, and we can explain our information. Yes, tell me any doubt right now. You have. Yes, student. Tell me any doubt.
No, sir.
So it is clear to all how we are representing our information in form of decision tree. Is it clear right now?
Yes, sir.
Yes.
Okay. So this is another example I am taking, and this example is different from the previous. As I told you, decision tree is completely supported by the two approach. One is a regression and the one is classification. When we're talking about the classification, then this diagram will help you to understand the decision tree with help of the classification. When we're talking about the classification, there would be only two options, either yes or no, true, false, or 0, 1. So the question comes in our mind to represent our information from the tree manner. Should I start the project or not? Suppose I am giving a project, I am assigning some activity. Then you are thinking, should I start right now or should I start after 2 or 3 days? So you have the two options. At a time, you need to filter your information. You need to filter your data based on your decision. So what you are deciding over here, should I start the project? That is a big question you have. If you are starting the project, then you will think as an employee of the company, if this project is important for company, then I will opt. Okay. So first you will see should I start or not. So what you are doing, you are choosing the option yes or no. If you're choosing the yes, then you will have the another question that is a condition. Is this project is important for the company or not? If it is important, if it is important, then company is trusting on my attitude, my behavior, and I'm just having this project. And if this project could be risky, maybe the on the time I will not able to complete. So this project could be risky, and maybe the company is trust on me, and company just investing in this project based on my attitude or my behavior. So the project is very risky. If I'm not completing on the time, so definitely it could be risky. And that is the point you are thinking always when you're looking for a company project. So, but if the project is very risky, then you should consider this part. I am busy with some different activity. I will not able to complete this project within the 3 months. But company is saying to us, you have to complete this project within the 2 months or 1 month. How I can? So it will be risky. I am not able to complete this project within the 3 months. But 1 month or 2 months is not possible. So I need take 3 months, 4 months for complete this project. So it is too risky. So again, you have the option. If it is too risky, then you will not consider this project for the company, and you will deny your request from the management. That would not be possible. Okay, if it is not risky, then you can start the project. Then, so what you're thinking? If I'm choosing this project, then what I have option? If this is beneficial for the company, then I can start the project because it is not risky. But you are going to the another part that is no set. So you will not ask to that that is to be you will not ask and not to be involved. So definitely you are not going to start the project. So there will be no more option. But after starting and choosing this option, then you will found at different level or its next level. If this project is a beneficial company, then you are saying yes. Then you found that it is too risky, and it is not risky. Then you can start. But if it is not beneficial for the company, but you found that is your management or management is trust on you, but it is not beneficial company, no issue. But is your management is trust on you, then manager is saying to you, you can go ahead the project. Don't think about the company beneficial right now. Think all about your career. So if you are involved with this project, then what you're doing, you will see maybe I don't think so about the industry right now. I'm thinking about the this is the good project and I should work on this project and this is the my career oriented project. Then if it is, then you can start the project, else you will not start. So what you are observing over here, if the project is not beneficial for the industry and as well as your career, then you will not start the project. But if you're founding over here, if project is industry oriented, your career oriented, then you will start the project without any doubt. And that is the simple meaning. Here we are identified by the classification. So what is the classification? You have classified your information based on your yes or no, based on your true false or zero one. And that is the options. We have the two options. But there is a condition on which you can filter your information from the two way. Yes or no, or true false or zero one. But when you're filtering your information into these two ways, and that is known as the classification. You're classifying your next decision based on your current decision. Okay, so that is a representation will be done by the tree manner. So we have the decision tree. Okay, and is it clear to all? Is it clear to all right now? Yes, will tell me. Is a simple explanation. I have told you how we are choosing the project based on the classification of our information. Yes, tell me, student.
Yes, sir, clear.
Okay, sometimes you have observed in your real life application after the 12th standard which degree you should opt. So you should go to the non-technical degree, technical degree. If you're choosing technical degree, then which degree you should choose, and if you're choosing this degree, then what is the stream you should choose. So what is your doing? You are doing the decision based on your condition. So whatever is the first condition, 12th start or 12th standard, technical, non-technical. So you have the two options, technical, non-technical. If you're moving to the technical level, then what you are taking a decision, another based on your technical or based on your query or based on your condition, you're choosing the next decision. Should I go to the technical degree, but to which degree I should opt, because you have the various option. Then that is the thing you need to keep in mind. And if I'm choosing this one, then what which branch I should choose? Okay, don't think about the right now your rank, but think about your career. If I'm choosing this branch or this field I share, then what would be my career? So you are looking for the future purpose and you are taking the appropriate decision. Entire decision tree that is followed by your life will describe your attitude or your career or future. What would be the expected? What would be the expectation after completion of this course and so on. So. And if because you have not gone through the non-technical, so you would not be bothered about the non-technical, because right now 2 years ago you have opted the technical course or technical degree. So this is your decision. A representation you are doing, so that is done by the decision tree. A same example I'm saying explain over here, the car buying decision may help. Should I buy a car? Yes, of course you can buy the car. So do you have should I use car or not? If I'm purchasing a car, if I'm buying a car, so which option I should? Yes or no? If I'm choosing yes, okay, I must choose the car. I must choose this yes option to purchase a car. You can do. But why it is required? This is a big question you should have before going to the yes. So if I'm choosing yes, then I have the another question. Why you are purchasing car? Because you are not need to go from hostel to anywhere. You are staying in the hostel, so why you are purchasing a car? So no need to, because the transportation facility, other kind of the facility is in the my local area. So we have the why we are purchasing car now. Petrol prices day by day is increasing. So why should purchase a car? And other thing we need to focus on maintenance, other things. So I'm increasing the lots of the I'm increasing the investment of the money, and that is not a good idea. So you need to take care of your transportation. Is it available or not? If it is available, okay, then it's okay, we will not purchase a car. But if it is not available, I'm staying into some other places and not staying in the hostel. I need to go to the university. Then I must have a bike. So I can cover the some time as well as I can save the time as well. Okay, time and money as well as, because transportation facility I'm using, so I'm paying lots of the money instead of the. I can use the carpooling, so I can adjust the money. I can save the my money and other things as well. So think upon your problem. What the problem you have, based on your problem, you will decide the decision tree. And if you're not purchasing a car, then why you're not purchasing a car? Then you can have the various option. If you're not purchasing a car, then you should have the another question. You can have depend on your requirement. Do I often travel outside my city? Okay, sometimes on the certain Sunday you always visit different cities. Okay, you are very roaming people who just like to visit different kind of city in each and every weekend, or maybe after 15 days you love to visit that city. Then what you are planning? You are not purchasing a car. There is no issue, but you should have a question. If I'm trying to purchase this car, then I can utilize my car after the 10 days, 10 days. Okay, in a month, I'm just moving from my city to the other city as well. So rather than the wasting the amount in the other transportation, it is right to purchase a car. So I can save some more money. And that is the point. So what is the problem you have? Based on your problem, you will decide. Now you will think this point. Why you have purchased a laptop? Before your degree, you will not like to purchase laptop. Why I should purchase laptop? Because in the 10th, 11th standard, 12th standard, okay, there's no need to purchase the laptop. Okay, I can manage, no issue. But when you're involved in the degree, your BTech degree, then you will think I should or I must have the purchase the degree. Or I might purchase the laptop. Why? Because It is necessity because whenever I need to perform any activity on the laptop or computer, then I can perform in simple way. I will not be depend on the any other student. I will not depend on the university's system. So each and everything I will keep into the my laptop. But that is a necessity. Think about the any decision. So based on the decision, based on problem, you can represent your thing by the help of the tree manner. So that's why we have the decision tree. And these are the three different example I have explained the thing. These are the regression example, and this is the your classification base, or this is a classification base. So having seen the image, you can easily identify which example belong to the which kind of the problem. Dysentery representation followed by the classification, dysentery representation followed by the regression. Okay, and this is just idea about the dysentery. Is it clear to all right now? The introductory part about the dysentery, is it clear? Yes, friend, tell me, is it clear to all right now?
Yes, sir.
Okay, should I move to the next slide?
Yes, sir.
Okay,
Yes, sir.
okay. So the point you need to understand, this is the important point. From this point, you need to understand why dysentery algorithm is required. Because you are saying dysentery, it is okay, we can. Why dysentery algorithm is required in the machine learning? So dysentery basically is most important algorithm in the machine learning where we can represent our information from the regression way or classification way. Why it is why it is needed in the machine learning? So here we have some point, some reason which describe each and everything especially. It is considered to be the most understandable machine learning algorithm, and it can easily be interpreted. So how we can say, because by the machine learning we can represent our information to two way, either yes or no, true false, or another way, or maybe in the way of just like we can say uh, regression. So based on dependent or independent variable approach you can do. So depend on the thing you can understand. And how we can say it is easily understandable? It is easily understandable by the graphical way. So see, we know the things, what would be the flow. So we can easily understand what would be the expected flow. So we can easily determine the thing. And as I told you, it can be used for the classification regression. So as I told you, no need to bother about the thing. Third point is very important point which describe the unlike the most machine learning algorithm, it work effectively with the non-linear data. From this point, I need to understand, can anyone tell me what is mean by the non-linear data or linear data? Can anyone tell me what is mean by the linear data or non-linear data? If you know the answer of the linear data, non-linear data, then you can solve or you can understand any problem. What is mean by the linear data versus non-linear data? Can anyone tell me? Yes, tell
Sir,
me.
in linear data, the data is like stored in a sequential manner.
Okay, that is the point. Any other student? Any other student? Please tell me. What is mean by the linear data, non-linear data? If you don't know this answer, definitely you can't do anything. You need to again go through the linearity information or the linearity information. This is 10th standard. 10th standard I'm asking, or 10th or 12th standard mathematics part.
Hello, sir.
Yes, tell me.
So linear data, the data what we getting maybe it will be in the linear form, and a
Okay.
non-linear data it will be in the polymer form.
Okay, this is good. So can you tell me how we can get the data in the linear way? This is my question. How we can get the data in the linear way?
Sir, I don't understand. Get from where?
Y is equal to mx, sir. That
I mean,
equation.
like, will we are you asking to are you asking us to convert from non-linear to linear, or to make it so that it is a linear data from the get by?
See, my dear, I'm asking very simple questions. What is mean by the linear data and non-linear data, and how we can represent our information in the non-linear or non-linear linear way? This is a simple question.
Oh, okay, so yeah, got it.
So our student is saying to me, sir, we will represent the linear way of the linear data. So that's my question. How we can represent? This is a simple question. You all are going to the right track, but just I need to see, are you on the right track or not? So that's why I'm asking the again next question. Just tell me.
So if we try to see the distribution of data, if the like the data points are in a sequential manner, and it increases with increase in uh, the like the plots or the x or y axis, then we can call it linear data, which increases over each increase in x or y axis. And if it doesn't, and it follows a different pattern, it doesn't like it both increases or decreases, and like is instead of either or case, if it both increases or decreases like a curve in as in a curve, then we call it a nonlinear data.
Okay, that is the point I'm getting. So it's simple answer. Your answer I can transform into the simple way so other student can understand. Just I'm explaining, and you have any doubt. Each and every student is having any doubt on any point, then you can ask me. I'm explaining one by one, step by step. Then you can understand. Just listen. As a linear data, we are saying so representation of the information will be done by the linear way. So linear way or sequential way. And here we have the very simple equation y equal to mx plus c. And this is the straight line equations which describe the data in the linear way. So with the help of this equations, we can represent our information. So what we have here, we have the two variables. One is a y and other one is x. So your information will be represented in the linear way, just like this one, as you can see over the slide. So that is the example of the linear regression, and that is the beauty of the linear data. So we can represent our data in the linear way, followed by our equation, that is the y equal to mx plus c, and why? Because it contains our information to be followed by the straight line manner. Okay, so this simple way. Is it clear to all about right now? Is it clear? Is it clear to all about right now?
Yes, sir.
Okay, if I'm moving to the another example, just like say, suppose I'm writing my equation mathematically, I'm explaining y equal to m1 x1 plus m2 x2 and so on so mn xn. What I have over here in the previous example, what we have the one independent variable, dependent variable. But here, what we have here, we have the only one dependent variable, but many independent variable. Those are the x1, x2, and so on, so xn. So with respectively x1, x2, and xn, we have its coefficient value, that is the m1, m2, and so on. So it couldn't have the many line like this one. Okay, I'm just explaining. Okay, so I'm just taking right now only three lines for understanding purpose. So line will be, or the data will be plotted in form of the sequential manner. It can followed by the different data, different independent variable. So we can say the all the data over here in these two example, linear or non-linear regression, or we can say the multilinear or multiple linear regression or multiple regression. We have the data in form of the linear way, and that is my point. So is it clear to all right now? By the polynomial way. So in this case, in the non-linear data, we can understand by the polynomial. So you can say polynomial. So if I'm writing here polynomial, then you can say, what do you mean by the polynomial? When talking about the polynomial, then we always prefer to describe the degree. So degree could be n. Okay. So if I'm just explaining my idea like this one. A student told me, sir, we have the one independent variable or one dependent variable. Suppose our information will be represented by the curve manner. So how to represent your data in a non-linear way? Now there is no straight line. Here we have the information from the non-straight line, or we have can the information in the non-linear way. So data means the information which is plotting on these lines. So that would be represented by the non-linear way. How to represent such information? We have the equation of the polynomial by which we can understand y equal to m1 x1. Suppose that. Okay. I'm writing another point m2 x1 square plus m3 x cube and so on so on so m3 x1 cube m mn xn to the power n plus c. Don't forget to put the c, that is intercept point. What is the point we are observing over here? We are observing over here, we have the one independent variable, that is x1 over here, and one is a dependent variable. And the x1 data will be plotting by their degree. So in the polynomial, what we have? We have the polynomial, that is the degree of power. Here we have the multiple power, that is the 1. Okay, that is the point we need to keep in mind. So y equal to m1 x1, y1 m2 x1 square, m3 x1 cube, and so on. So mn x1 x1 to the power n. So we have only the one dependent variable and one dependent variable, and data will be plotted by in the form of the curve manner. So here we present our data in form of the non-linear way. Now, after observing this point, can anyone tell me what is the biggest difference you have observed to identify the biggest difference between the non-linear data and linear data? Can anyone tell me?
So in linear data, we have a linear equation, whereas in non-linear, we have a polynomial equation.
That is a good point, but you can observe the point over here in the linear data. We can represent our. It is a degree. Good. So by default, we have the here degree. That is the value we can identify. We can represent the maximum degree would be 1, but here the maximum degree would be n. Depend on the your polynomial features. Same thing you can say in the polynomial derivation example. We have defined the polynomial degree when we use the polynomial feature method. That is a big difference we can identify. In the linear data, always degree. So I can write over here the always degree will be 1. But in the case of the non-polynomial, degree can be vary from the 2 to n. Why I'm writing 2? Because if you're writing the degree 1, so there will be no difference between linear or non-linear data. So you can say the maximum degree would be n, but degree minimum should be 2. So we can distinguish our information from the polynomial way. So linear or non-linear data, this is the biggest difference. Now, is it clear to right now? Now, is it clear to right now? This is the biggest difference.
Yes, sir.
Yes, it's clear.
Yes, sir.
And now, yes, this is my point. After understanding this point, now you can understand again back to this point why dysentery algorithm is required. So unlike most machine learning algorithm, it works effectively with the non-linear data. But when talking about the other kind of approach, which is not much effectively. So that's why what we have seen, we have the polynomial regression. So if we see the polynomial regression and dysentery, so dysentery provide the better result. And that's why the dysentery is required. For describing the third point, I need to explain this idea. And it is necessary part for understanding the third point. So we are understanding the word dysentery algorithm. So first we need to understand it is understandable for the machine learning is simple, be interpreted easily because we know the its flow. And it can use the classification regression problem. Of course, I can agree because it is a concept of the dysentery. And third part we have seen by the mathematical representation. In the next slide, we have seen. I'm talking about the fourth one. Constructing a dysentery is very quick process. Why? Because we will split our information on the base of the features. Let me explain this example in simple way you can understand. What was the problem I have asked? Now, difference between the your data. So data is what my one feature. So I'm filtering my feature based on the linear non-linear. So what I'm doing, I'm classifying like this one, linear or non-linear. In the linear, what I have the linear regression, or I can represent the, or I can represent the single. Okay, I can write the single independent variable, or I can represent the multiple independent variable. In the non-linear, we have the different kinds of approach. So as according to demand, we can do. So what is the condition over here? What is the type of the data? Here I'm talking about feature, that is the type of the data. After understanding this feature, we are splitting this feature based on our requirement. So we have the linear type data, non-linear data. From this linear data, we can filter our information. We can expand our tree based on our requirement. So that is the number of I. Number of means number of the independent variable. The linear regression or linear data, we have single or multiple. So this is the point. And what we are doing, observing over here, we are representing our information in form of the tree manner. Constructing this entry is very quick process since it uses only one feature per node to split the data. So each and every node we use one feature to split our information. So that's point describe the why this entry algorithm is required. Now is it clear to right now?
Yes, yes, clear.
Okay. Now just let me move to the next part. So what is the advantage, disadvantages? Yes, of course. Advantage is saying to us, decision tree generate the understandable rules. Yes, of course, it is clear because you have the problem classification or regression. Then appropriate the based on the appropriate problem, you are moving, you are writing your solution or the rules based on your problem. It could be regression or classification. And how we are doing, depend on the independent variable, dependent variable. So we can say regression we are following. If we have the classification based information, so we are following the classification based decision tree. Decision tree perform the classification without requiring much computations, of course. Now, in the classification, you need not to write the long code. You need to write the many things. It just identify the information based on the its filter way. What is the filter way? So based on just like the linear, non-linear. So we have filter, and according to that part, we will jump to on those parts which are required to the our problem or our solution. So here we will not bother about the much computation as a normal classification problem we have, just like the KNN, just like the logic regression, so and so. In the logic regression, we have to use logit function. Okay, so that is a function which require the your data into the classification base. But here we will not bother about. Here we have the simple code by which we can easily classify. So no computation, no more and more computation is required over here. It has only simple computation by which we can do. So this is a big advantage. Tree are capable to handle both date kind of data, of course, continuous. If we have the continuous kind of the data, so we are having the regression problem. If we are having the category based data, so we are talking about the classification problem. And now decision tree provide the clear identification of which fields are most important for the prediction classification. So what I have planned, I have the two simple code, and I will use some data set to explain the decision tree followed by the determine the prediction, and decision tree followed by the classification, by which we will implement the same code into the our system. And how to build the decision tree? That is the entropy of information gain. We have some algorithm, but that is to be the part of the data. But in the Python library, what we have the predefined decision tree classifier or decision tree regressor. So we will not much bother about the long and long code. We will just use the library to predict our information or to classify our information. And that is a beauty of the Python library. So we will use those parts. So this is the biggest advantage. These are the so many advantages by which we need to bother about the decision tree we should use or not. So of course we should use. Disadvantage is saying to us in different way. Disadvantage is you can understand that is a decision tree are less appropriate for the estimation task where the goal is predict the value in the continuous field. Here I'm just saying to the important term you need to keep in mind. Most of the time, when you're looking for the decision tree, I can say 80 or 20%. So, or maybe the 75, 25%. 25% we will use the decision tree for the only the prediction purpose. But 75% or 70% I can say it is used to identify the problem for the classification. So when you are looking for any problem which is following by the decision tree, then you will observe this point. The particular problem is based on the classification. So, but at the time you need to identify. So that is the point we need to choose the appropriate steps. So 75% or more than 7 to 75%, you will see most of the applications, most of the problem are based on the decision tree followed by the classification, not a regression. Regressions only about the 30% or we can say the 25%. So that is the point we can say that when looking for the good prediction or good estimation, decision tree is not a good way at a time. And we're talking about the its error. So decision tree are prone to the error in the classifications problem. But what type of the classification it's good. But again, we have the problems. What is the problem here? It is prone to the error. So when solving the problem with the classification, it gives a error. It provides a more error. So that is the big problem we can identify. But when talking about its biggest disadvantages, so I have circled or have just put into the black color line. You can see dysentery can be computationally expensively to train. Why? Because whenever you use the decision tree and we will need to train the model followed by the decision tree approaches, it takes much time. I have been observed so many times, and when I'm just writing the code, I'm trying to do something on the decision tree that I found compared to the linear regression or any kind of regression approaches. Decision tree takes much time for filter our data involve the training or testing. So while training our model or while building the model, decision tree takes the much time followed by the training data. So it requires the much time. So computation is just would be a little bit complex. So that is the point we need to keep in mind. It takes much time for the computation, but we will not touch its disadvantage part. We will see its advantage part where decision tree will be applicable, and that is the advantage disadvantage part. And here, why it is taking the much computation. So just let me explain this idea in simple way, then you can understand. Let me explain this example in simple way, then you can understand. See, you can note down the some point over here. We have the pruning algorithm. So what is mean by the pruning algorithm? Pruning algorithm is saying to us why or why it is the much computation. I'm explaining. It supports the pruning algorithm. Pruning algorithm means whenever you need to search, you can have the two options. Either you should choose this one or this one. So to of the best attribute, best feature, or best decision, it takes internally it takes much time. Internally it takes a much computation. So that's a big problem. We can say recently by training the model, it takes much time. How? Why? What is pruning algorithm? Pruning algorithm, we can say, suppose I have the problem where I need to choose the its minimum value and maximum value. So I can choose min. When I have need to choose minimum value, or whenever I need to choose maximum value, then I can choose max. And in artificial intelligence subject, you have studied this algorithm that is known as the min-max algorithm. In the min-max algorithm, especially used for the gaming purpose, whenever you need to choose the minimum value or maximum value to decide the to decide the your appropriate value. If I'm choosing minimum value, then I should go to that part. If I'm choosing minimum value, then I need to maximum value, then I need to choose this path. So the entire decision path will be based on your minimum max value, and that is the algorithm you have studied into the pruning algorithm. That is the minimum max min max algorithm, and that is the part of the searching. So where we need to search our information, and we need to go through that part. Another algorithm you have studied A star algorithm, EO star algorithm. Those are the local search area, local searching algorithm. So artificial intelligence also supports the pruning algorithm in which we need to do so many things, we need to search so many things, but internally it takes much time to take the best decision. So definitely decision tree to train the model, to building the model, definitely it takes much time. I'm taking a simple example. Suppose you need to go to anywhere. So you will take 1 day to decide should I go or not. Why? You are taking much time to decide your to take the appropriate decision. And once you have taken the wrong decision, so definitely you're out of the room. So for giving the best and better result, you will take much time to say your parents or family member, I need to take much time to decide what should I do or should I go or not. So just give me 1 day rather than the 1 second and 1 minute. So you will take much time for the computation internally in your mind to decide you should go or not. And that is my point. So that's why decision tree will take much time for the computation. So pruning algorithm is what? Definitely you know it is very expensive. Why? Because it will decide internally a best appropriate decision. Or it's a method, it's a algorithmic way. So definitely what we are doing, we need to say that disadvantage will be it's expensive in terms of that term. That is the big point we need to keep in. So now these are advantage, disadvantage. Now is it clear to all right now? Advantage, disadvantage part. Tell me any doubt, please. Student, tell me any doubt.
No, sir, no doubt. No, sir.
No, okay, good. So thank you. So what is a decision tree? Ultimately, what is a decision tree in your after learning the theoretical part about the decision tree? What is a decision tree? Decision tree basically supervised learning approach of mathematical, which looks like the inverted tree. Can anyone tell me what is mean by the inverted tree? Can anyone tell me what is mean by the inverted tree? Wherein each node represents a predictor variable, that is a decision tree, or this is a decision node, or we can say it is a feature, and the link between the nodes represent decision, and each leaf node represent the outcomes. Just tell me, can anyone tell me? Can anyone tell me what is mean by the inverted tree?
So basically, it means that in a normal tree we have a single root node, and it segregates into different branches and more on them to form a proper tree. But in case of an inverted tree, the thing is totally opposite. We have different kinds of features, and all the features one by one converge with each other, form different types of combinations, and eventually come to a single result at the end.
I'm totally agree with you, but
It's just
invert.
like tree, but it is upside down. Like we have root at the top and leaf at the bottom.
Okay, this is a brilliant answer. Of course, in a normal tree, what we have the root over here, and then we need to see other its branches, other branches, and then we like this one. Okay, and according to suppose we have the sub branch of this root, so we can like this, and like we have the another more branches, so like this. So this is what we are doing. We are seeing each and everything from bottom to top. That is a normal tree, in a general tree. So this would be a root. Okay. But when talking about the tree representation for information, so we represent our information from the top, and that would be the root. Okay. So again, like this one, and this one, and this one. So that's why it is known as a inverted tree. Like this, like this. You can see this right now. Is it visible to all right now? And in this, I have the inverted tree or reverse tree, we can say. Okay. Now this part is clear. Tell me, this part is clear.
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
so good. So after this point, you can observe over here, our distant tree has the following structure. So root node. So what is root node? We know. So no need to discuss more over here. What is internode? We know. We know what is internal node. What is the leaf node, terminal node? We know, and we have seen this concept in the tree data structure, and what are the branches as well. So theoretically, we don't need to bother about all the aspect, but by the diagram, I can explain. This is your root node, okay, and this is root node that is also known as the first node, and this first node also will be the decision tree, decision node. And because based on the condition, you will choose the appropriate decision. Either you should go here or here. And after this point, if you are identifying that based on the condition you are moving here, then based on this would be your left node and this would be your right node. So this will be your right node and this would be your left node. On the left node, we identified by there are some other conditions on which we need to expand our data. So here we are expanding some information over here. So we have the its left to left node. We can say I can write like this one for understanding purpose, and we have the left to right node. So that is a descent. At this level, we also identify we need to filter our information. So we have this one. So this is a leaf node, and this is the left node and right node. And at the last, we are not expanding any node, so that node is also considered as a terminal node or leaf node. Same thing, we can go through the right side, descent node and leaf node and leaf node. You can say, you can observe here the important point over here. From root node to leaf node, there are the other intermediate nodes are available. Okay, those are known as the internal node. So I can say this would be, and that point also I can consider like that would be our internal node. Okay, so that is also known as the internal node. That will also identify by the internal node. Okay, so this is just idea about when I told you about the what do you mean by the decision node. Decision node, every node is also known as decision node on which we are taking a decision. A node which is required to take some decision, so it is also known as the decision node. And decision node can be an internal node, decision node can be a root node, decision node can be a intermediate node. But keep in mind, internal decision node cannot be leaf node. If you're writing, if you're saying internal node can be leaf node, how it is possible? Because the leaf node will not, we are not spending beyond the what we are our concept, we have our node based on the leaf node. So how we can say? So leaf node will not be treated as a decision node. That is the point we need to keep in mind. So it will not be equal to decision node. Okay, so I'm writing simple normal way decision node. So leaf node cannot be equal to decision node. This is the point. Yes. Tell me any doubt. Is it clear to all right now about this point? This is a
Yes,
point. Okay, so something we need to keep in mind in the decision tree, and this is a critical point. Okay, let us see another example. Rather than wasting much time, I'm focusing on a simple example to elaborate my idea. Suppose you have a plan. You have planned. Okay, when you're planning to organize a party, I'm taking simple example to explore my idea. That's why. See, you need to decide how many guests will like to eat non-veg or veg. So based on this observation, you will share your information to the your guest. So you will asking your information from the different way like the survey or other kind of. So you are representing your information in different way like this one. Did the guest eat chicken? So guest is saying no. So you will choose. You will ask another question. If did the guest eat chicken? So yes. So you say that is a non-veg. Okay, non-veg. So definitely you could do that guest into the non-veg category. But you are asking the same again question. You are not interested to eat the chicken, so maybe you can eat the another non-veg item. So I can ask another question. So he is saying yes. So did the guest eat mutton? Say yes. So again you will put into the non-veg to him or her. But he's saying no. I don't like to eat chicken, but I don't like even I don't like to eat the mutton, but I like to eat the seafood. So you will be considered as a non-veg because after all you are eating non-veg, and that is the representation of our decision based on your requirement, based on your problem. So each and every level you are asking the question. So this question is considered as a condition. Okay, all these part are identified by as a condition. So you are choosing the appropriate condition and you are taking the decision, yes or no. So what you are doing? you are making the data, you are making the information from the classification. So did the gas eat mutton? Yes or no? So yeah, finally, did the gas eat seafood? So finally, it observed that each and every time gas is saying no, no, no. So finally, what he is a non-based, he is a based person. Okay, and finally, he is getting the say. If once a time he is saying yes, so what he is able to, he will be considered into the non-based category. Now see. So structure of the decision tree of the previous example, as I told you, you can say that would be a root node, and that is also known as decision node. And in which we have the some branch in which we have the internal node, and that is also known as the intermediate node or decision node. Okay, you can observe over here, and the last we have the known ways and ways. So this is your leaf node, because from this point we are not expanding our any node, and that is a simple concept. So ways and non-ways would be the leaf node, because we are not expanding our detail. Why you are not expanding? Because finally we got the our answer. So when we got the our answer, we predict the information, so we will not expand our information. We will not expand our decision based on our next question, next condition, or next requirement. So that is what we have the decision tree. So this is the fundamental idea about the decision tree, where we have seen what is mean by the decision tree and what is the application of decision tree. So today what we have observed here, we have seen decision tree basically use is an approach which is used into the two kind of the approaches to solve the problem of the classification regression. And we have the what we have observed, we have seen a regression based decision tree example, just like for the playing and non-playing. So we have seen, and this is the classification based example, and this is also classification based example. And we have the seen why decision tree algorithm is required, followed by the about this mathematically, where we need to identify what is the difference between the linear data and non-linear data. After understanding this point, we have seen the advantage, disadvantage part, and we also observe why it takes much computations. So based on the pruning algorithm, and that is part of the AI, because searching is in the AI, searching takes much time. So we have the different kind of algorithm like A star, EO star, min max search, and so on. So yeah, alpha beta pruning algorithm. If you remember the AI, so we have the alpha beta pruning algorithm. That is the best algorithm for the searching purpose, especially used in the game. And why decision tree is algorithm? So what is the decision tree algorithm? So we have this point, and this is some point which describe the decision tree internal factor, and that is represent the structure of the decision tree. So for solving any problem, we can represent the structure. So what is the structure of decision tree? That could be identified by the various points. Those are the root node, decision node, branch, internal node, intermediate node, and leaf node. So you have to keep in mind all these points which describe the structure of a decision. Okay. So from this point, I can say simply, do you have any doubt? Then you can ask me.